where in the world you are. Say good morning. Hello, good morning, good afternoon, and good evening, everybody, depending where you are in the world. I will say good morning because I'm actually currently based in our new Sydney data center, sitting in our office streaming live to you from there. So thank you for joining me for my chat. The only thing between you and your customer is a data center. Quick introductions. Who am I? My name is Nick Geyer. I'm a staff network architect for our Internet Edge and Backbone networking team. I started with DigitalOcean in February 2016, so almost at the 7-year mark. And what a ride it's been in those 7 years as well. I am typically based out of Canberra in Australia, which is the capital city, a few hours south of Sydney. When I'm not there, you'll typically find me over in New York, based out of our head office there in Manhattan. Couple of personal things about me. I love snow sports, especially skiing and snowboarding, and I love motorsports as well, both watching them and participating, but not as good participating, I think, as a lot of the people I watch on TV. I also have a wife and 3-year-old twins who are over in the US at the moment still. So just a very quick shout out and hello to them because they're on the other side of the world at the moment and I believe they're watching. So a quick overview of what my session's about. Basically, I'm going to give you a very quick look under the covers of our new data center, Sydney. You'll get to see some things about what makes it tick and what makes it work and where your customer's actually stored and where your data's actually stored and where your applications run from. And then obviously I'm from a networking team, so a specific focus on some of the networking elements as well that we've put in place here. What I hope you'll take away from today, a bit of a better understanding about what happens inside a DigitalOcean data center and what it looks like and how we build it. A lower level understanding of how we build our networks and specifically the ones that connect you to your customers and your applications. And build a level of confidence that we can be a trusted partner, especially for internet connectivity, because it is extremely important that you and your customers have extremely good network connectivity to our resources. So to start off, welcome Sydney. Obviously it went live today, a couple of hours ago. Yeah, very, very excited about it. And as an Australian, I'm especially excited about it and very, very happy to see we're open in Sydney now. So just a quick couple of points about the facility itself. The picture here is actually the facility that it's located in, and I'm actually sitting in at the moment in one of the office spaces there. It is a brand new facility. It first opened in November 2019 for the first stage, then subsequent stages have opened since, and we are located in the newest and latest iteration of this facility. It has a total of 54 megawatts of power, so plenty of power. I believe it can host up to 9,200 racks. And it has N+1 at a minimum M&E redundancy, which means mechanical and electrical. So all components here obviously have all their primary systems and then at least one failover system for redundancy as well. So that covers off power, cooling, water supply, chillers, absolutely everything in here. And that's tested quite frequently as well. It also has phenomenal security here. I think in one of our marketing videos that the facilities manager, Dan, is in, you'll see there is at least 7 layers of physical security you have to go through between the street and between getting into the racks where our servers are located. So that's a mixture of biometric security and also physical personnel security, where we have to present ourselves to on-site security and they validate physically that we are who we claim to be. We have a lot of local resources here as well. So we have invested into this heavily. We have an office co-located within the data center itself. We have a data center manager on site. We have data center engineers on site. And then across Australia as a whole, we actually do have a lot of staff here already also. We have quite a number of network staff here. We have security staff here. We have business development and user experience staff located all across Australia as well. So that complements the global resources DigitalOcean has in place to support you and your customers. Quick slide on some of the build pictures. The one on the left is what we started with about 6 months ago. Basically an empty hall, lots of hardware, and a lot of hard work ahead of us. And then on the right, this is coming towards completion of the build, but you'll see, basically how we rack and stack servers and lay things out. And this is something we take a lot of pride in. We get custom manufactured racks for ourselves. One, they look cool because they're painted in DigitalOcean blue. But all of the cabling and things you'll see there on the right-hand side, we do locking cables so that way they can't easily fall out just from being bumped or touched. We use different color coding to identify things. So obviously blue and red power cables to identify A and B power feeds. The network cabling in there as well, and it's all very structured and very neat, and that helps ensure that your resources in your applications stay online. There's not a mess of cabling in there that can result in oops as humans go and interact with any of that equipment as needed. So I mentioned in the introduction that I work for the Internet Edge and Backbone team. Quick summary of what that is. We provide the front door between the world and DigitalOcean data centers. So what that actually means is we provide the connectivity out to internet peering and transit networks. So, when you're accessing us, things route over the internet, and then it comes in what we call the front door into our portion of the network, and then we hand that off to the data center. We also operate the private backbone network we have between our regions around the world. And it's designed and implemented like a global service provider style network. So it looks more like a telecommunications network, more than like a sort of enterprise network. Lots of routers, lots of cool technology, including BGP, MPLS, and segment routing. It is IPv4 and IPv6 dual stack native. So we don't do any weird tunneling mechanisms. It is, we treat them both as first-class citizens. And at the bottom, there's a link to our Peering DB page. What Peering DB is it's a central repository of peering information for internet-connected companies. And that gives a good breakdown of sort of what bandwidth we have where, what internet exchanges we're participating in, and sort of, physical geographical locations of where we operate. So there is a diagram here also that gives a very high level overview of this backbone network. So it does truly span around the world and completes 360 around it. Obviously, down in the lower right-hand corner, you can see Sydney's now connected there as well, up to Singapore and out to California in the USA. So a bit more in detail about the network design itself. Probably the first thing to mention is it is actually a brand new design. This is the first implementation of this design. We've obviously tested it extensively, but it's the first production implementation of this design. There's a couple of cool, I guess, design choices that have been made in this. The first, it's a clove fabric design. So it's sort of represents a traditional spine and leaf type network. That allows us to horizontally scale individual components of the network as required. So if we look at the diagram where we have access routers for the internet access layer, we have 2 primarily deployed on day 1, and then we can continue adding more and scale horizontally as required. We've also broken it apart into independent functional components. So we have specific devices for internet access, which is what connects to the peering and transit networks. Core routers, which is the spine layer of the network and also does all the backbone connectivity, and then another layer of access routers, which connects down into the data centers. A big benefit of this design is it improves resiliency and minimizes the blast radius when failures do occur. So as opposed to having larger, I guess, chassis-based boxes that did everything, breaking it out into individual components means when we lose one component, it affects a smaller portion of the network as opposed to taking out large portions of the network. It also means we can optimize the device selection for each function. And that's what we've done here. We've specifically picked devices that are great at the role that they've been chosen for, instead of sort of trying to pick something that caters for everything. And it is 400 gig Ethernet enabled. They are all native 400 gig Ethernet devices. In Sydney specifically, it's the latest generation of Juniper PTX routers. They're future-proof to ensure, the continuing ability to scale. And we are also starting to test 800 gig platforms in early 2023 as well. In terms of that front door connectivity, in Sydney specifically, we use a blend of peering and transit from the major providers within this part of the world to ensure redundant and resilient access for you and your customers. So we have a mixture of transit providers, which is Telstra and Vocus. They're two of the largest service providers in this part of the world. And then we're also on two of the largest peering exchanges also here in Sydney, which is EdgeIX and Equinix Internet Exchange. I won't say specifically how much capacity we have, but it's N by 100 gig to all of them. So total volume of bandwidth is approaching sort of the 1 terabit per second in terms of total connectivity. In terms of international connectivity, we've actually put a lot of work into this for Sydney. It's used, we use it to interconnect Sydney to the rest of the DO global backbone network. We have multiple connections from Sydney going out to Singapore and multiple connections from Sydney going out to the United States as well. I've included some of the cable systems we use there to demonstrate the diversity, and we do have end-to-end diverse paths. And a key point that I do like to make is we use optical wavelengths only, and we procure those from the submarine cable operators or consortium owners directly, rather than using third parties. So there's a diagram on the right here which gives an overview of how Sydney is connecting to the rest of the DigitalOcean network. We have multiple wavelengths that are diverse end-to-end going out of Sydney to San Jose. Then we have 2 legs from Sydney to Perth on the western coast of Australia. One of those segments is what we call dry and runs terrestrially across the Australian continent itself. And then we have a wet segment that runs from Sydney to Perth through the sea underneath Australia. And then out of Perth up to Singapore, we have diverse connections running there as well. So I think some key points for Sydney. It has been built with the latest generation routing equipment and network design. The interconnection strategy we've employed here with our transit and peering partners does actually provide us single hop access to over 75% of the residential service provider networks in Sydney. The remainder are 2 hops away via usually 1 single peer or 1 single transit network. So the connectivity there is extremely good. We're extremely proud of what we've been able to put in place there as well. The private backbone built to Singapore in the United States, we've done that using the lowest latency links that are commercially available with end-to-end physical path diversity on all routes. And as we move forward, you'll see we start to backhaul all international traffic ourselves. And the reason we've decided to do this instead of just putting it onto transit networks in Australia is so we can control that end user experience a little bit better. It's basically getting you and your customers onto our network as quickly as possible rather than routing things over the internet. Now, here's probably one of the most exciting parts, which is key points for the rest of the world. We are actually already in the process of deploying this new network design and hardware to all regions globally. So over the sort of coming weeks and months, you'll start to see this get turned up around the world. As sort of mentioned already, the new design significantly improves resiliency, scalability, and the failure recovery of the network, ensuring you and your customers can always access your resources. So One key example of this with the current network in certain failure scenarios, we can be looking at recovery times of 5 to 10 minutes, whereas this new network is typically fully recovered in about 60 seconds. And that's something we're driving towards is, unfortunately, the reality is failures do occur, equipment fails or links fail from time to time. But it's, we're putting a lot of effort into when that happens, ensuring it has as minimal impact as possible. So why is this important for you as a customer? We've set a KPI internally around, how do we measure success on behalf of our customers, and we've come up with what we've defined as a usable experience. The definition of a usable experience is ensuring that you and your customers experience minimal packet loss, jitter, or suboptimal routing resulting in excessive latency. So that's what we're continually striving to meet. And that's an iterative, ongoing thing. It's not something we do once and then say, hey, we're done. This is a continual iteration and changing, ever improving, getting you and your customers onto our network. We are making considerable investments into this new network, provides a lot of benefits. We're removing aging equipment before it fails and replacing it with the latest generation of equipment. Globally, we're optimizing all of our connectivity at the moment as well. So, you'll start to see the network performance increases further beyond what it is already, and we start to get closer to you and your users, which is that we want to get you on our network as quickly as we possibly can to minimize third-party or internet disruptions that are wider in nature. And one of the other things we're driving heavily is optimizing our monitoring and tooling to better detect and mitigate negative events. So whether that's hardware failure or link failures or things like that. And the intention is, as we move into 2023, we will start to expose some of that tooling to customers as well, because I think that's some feedback we've taken on seriously. Is when there is a network event occurring, we don't necessarily expose enough tools today that you can do your own interrogation and investigations as to how the network's performing. So that's quite exciting, and we're looking forward to releasing some of that tooling next year. But yeah, so based on this, you can be assured that we are continually iterating and investing into the network to improve that usable experience, and that's what is driving us forward and will drive forward, or the continued iteration of the network. Yeah, so to start wrapping up some of these slides, it is. We've got a picture here. These are actually the two internet edge racks that are in Sydney. So that's what they look like. That's the production deployment, the production equipment. We've also further iterated a couple of things that, lessons learned over the last few years operating the existing network. We're now, there's one single standard for global deployment of this network. Some of the benefits that drives is it's consistent and repeatable deployment pattern. Where that really shows its strength is there's no special cases. So when humans do have to interact with this part of the network, be it configuration or failures, we're not sort of guessing, okay, how is this part of the network configured? It's one standard deployment. So it's deployed cookie cutter the same everywhere. And that even comes down to the cabling that's being used as well, which is, leading into the next point, everything is now pre-cabled. Why have we done this? To minimize the physical human interaction with the equipment. We've noticed, a lot of the failures or issues with equipment can be when people are physically interacting with it, whether it's accidentally bumping a cable or a fiber cable or an optic in the equipment and knocking it out. So everything is pre-cabled now. So there is no touching of the physical equipment anymore. Any connectivity to third-party networks happens in a meet me room, which is just a passive environment. And the automation of the network as well. We do extensive automation today, but we're expanding it even further using lessons learned from the existing network. Again, improving things, getting more automated testing occurring on any changes that are made to the network, and reducing that human interaction with the equipment as much as possible. So with that, I'll be wrapping up now and open to taking questions for a few minutes. And yeah, thank you for your time, and thank you for listening to me present on Sydney and our network in a little bit of a deeper layer.